Hello everyone, I am Mr. Swapnil Joshi, proprietor of Joshis classes. Today we are going to understand the concept of differentiation, which is very much useful in 12th standard as well as number of subjects in engineering. In engineering we are having certain modified topic on derivative, and that is called as partial differentiation. And if you want to understand the concept of partial differentiation in detail, first of all you must be perfect in total differentiation, or we can say differentiation. So our topic is differentiation. In other words, we say that derivatives. Now whenever we are talking about derivative, the first important concept that should be clear to you, and that is regarding dependent and independent variable. So let us see that y is equal to fx. So whenever there is y equal to fx, y is always called as dependent variable and x is independent variable. See that for this relationship y equal to fx, dependent variable is 1 y and independent variable is x, that is also 1. Now here it is not necessary that every time y is dependent and x is independent. You can also change, you can also say that x is a function of y. Okay. So now x is dependent, y is independent. Now you can also say that is m is a function of t. Now we can say that m is dependent variable and t is independent variable. So the concept of dependent and independent variable must be clear, because whenever we are taking the derivative, we always have to take the derivative of dependent variable with respect to independent variable. Now we will see the definition of derivative. Actually derivative means rate measurer. Let us assume that there is a small change delta x occurs in x. So naturally, since y is dependent on x, naturally there will be a change in y as well, and again that change will be very small, that is delta y. Then limits as delta x tends to 0, delta y upon delta x is called as derivative of y with respect to x, and it is represented by the symbol dy by dx, or sometimes we can also call it as f dash of x. So definition is dy by dx is equal to limits delta x tends to 0, delta y upon delta x. Always remember, derivative is a rate measurer, and this definition is called as Leibniz definition of derivative. Here dependent variable is y, independent variable is x. With this relationship x is equal to gy, we can say that derivative is dx upon dy. With this relationship we can say that dm upon dt. Always remember, for a derivative dependent variable appears in the numerator. Here we can see that dependent variable occurs in the numerator. Now let us understand geometrical meaning of a derivative. Y equal to fx represents two-dimensional curve. For example, if I draw a curve and if I draw a tangent, here the slope of this tangent is given by dy by dx. So remember that for a relationship y is equal to fx, the derivative dy by dx or f dash x always represents slope of the curve, or slope of the curve means what? Slope of the tangent to the curve at that point. Now here if you shift the point, if you take the tangent at this point, so let us see that slope of the tangent is different. You must be knowing this, for a straight line slope is always constant, but for a curve slope is changing at the different point. Here if I take this point as A, if I take this point as B, as we are going from downward direction to upward direction, observe that slope of the tangent is increasing. So this is important concept, that geometrical meaning of a derivative is nothing but slope of tangent to the curve at a particular point. Okay. Now let us proceed further, that derivative by first principle. Whatever definition we have taken earlier, that dy by dx is equal to limits delta x tends to 0, delta y upon delta x can be written precisely as dy by dx is equal to limits as delta x tends to 0, f of x plus delta x. So, what it means? So, y is equal to f x is the original function. There is a small increment in x, and that is why value of the function increases to x plus delta x. So, this is a incremental value we can say, and then if you subtract original value from this, then we say that it is a difference in the incremental value and original value. That itself is called as delta y if you have seen earlier side. Then in this case, limits as delta x tends to 0, f of x plus delta x minus f x upon delta x. So, this is the formula called as first principle. Why it is important? Because all formulas of derivatives are derived with the help of first principle, that you are aware about. Derivative of x is 1, derivative of tan x is sec square x, derivative of log x is 1 upon x, derivative of e raised to x is e raised to x. So, all these standard formulas are derived with the help of this first principle. Okay. Now, let us proceed further. Derivatives of standard function. So, here I will just keep this slide for 2 minutes, so that you can read out all the formulas. Okay. So, we can read out all these formulas one by one. I think that you must be aware of all the formulas. For example, particularly you should know this: derivative of root x is 1 upon 2 root x, derivative of 1 upon x is minus 1 upon x square, derivative of 1 upon x square is minus 2 upon x cube. All other formulas are common, but most of the people do not find out or cannot find out these derivatives properly. So, remember particularly these formulas. So, just read out all the formulas before going to further slide. Derivative of sine is cos, derivative of cos is minus sine, then derivative of sec is secant tan x, and derivative of tan x is sec square x. So, these are all basic formulas, and all these formulas are derived with the help of first principle. So, remember all these formulas all we require while solving the examples. Now, next an important topic, rules of differentiation. U and V are the derivable functions of x. What do you mean by derivable functions of x? The functions whose derivative can be found out or whose derivative can be defined, and k is a constant term. So, here we can say that d by dx of ku is equal to k into du by dx. In short, as derivative of constant term is 0, and that is why that k must be taken outside, and we have to take the derivative of only u. Now, we can see this example: d by dx of 7 into e raised to x, 7 must be taken outside, and then we have to take derivative of e raised to x. We know that derivative of e raised to x is e raised to x, and that is why final answer is 7 into e raised to x. This is rule number 1 we can say. Now, next rule is sum and difference rule. Actually, sum rule and difference rule are different, but just to save the time I have combined it just by writing down plus or minus. So, du by dx of u plus or minus v, what to do? We just have to take the derivative of u and v separately by writing down plus or minus in between. Let us take an example: d by dx of sin x plus log x, and that is why we have to split it into two parts, that is d by dx of sin x plus d by dx of log x, and you must know the formula: derivative of sin x is cos x and derivative of log x is 1 upon x. So, this is sum and difference rule. Now, number one important rule, and that is product rule. Most important, we will require this in many topics in our further education. Whenever there is a product of two derivable function, d by dx of uv, simple way is there, that is derivative of first term, second term you have to keep as it is, then plus we have to take the derivative of second term keeping first term as it is. and then here we have to find out the derivative of root x into 5 raised to x. So, we can say that root x is u and 5 raised to x as v. Whenever we solve the example, we have to remember the formula, but no need to write down the formula. We can use this step, that is derivative of the first term into second term 5 raised to x as it is, then derivative of second term keeping first term as it is. Now, let us take the derivative of root x, and derivative of root x is 1 upon 2 root x, and derivative of 5 raised to x. What do you mean by 5 raised to x? It is in the form of d by dx of a raised to x. We know the formula, derivative of a raised to x is a raised to x into log of a, and here instead of a there is a 5. So, here 5 raised to x into log 5. It is always better to give the answer in simplified form. Here observe that 5 raised to x is there, we can take it common. So, 5 raised to x into bracket 1 upon 2 root x plus root x into log 5. So, we have seen the rule number 1, that is d by dx of ku, k must be taken outside and we have to take the derivative of u. Then second rule we studied, that is sum and difference rule, and now third rule that we have studied, that is nothing but the product rule. Okay. Now, let us proceed further. One more important rule, quotient rule. Quotient rule means we can say that ratio of two terms u and v, d by dx of u and v, the formula goes in this manner, v into du by dx means here we can also remember this formula in this manner. So, d by dx of u upon v, so u is in numerator, v is in denominator. So, v into du by dx, so we can also say that is denominator multiplied by derivative of numerator, I am calling n for numerator, then minus numerator as it is, that is u, multiplied by derivative of denominator, I am calling capital D for denominator, and then we can take denominator square, that is v square in short. So, you can remember the formula either by remembering u and v, or also we can remember with the help of denominator and numerator. Let us understand this formula with the help of one example, that is d by dx of sec x upon x cube. So, sec x is acting as u, x cube is acting as v. So, let us see that if according to formula v into derivative of numerator. So, x cube as it is derivative of sec x, then minus sec x into derivative of x cube, and naturally in denominator it is a square of denominator means x cube square. Simplify it by using the standard formula, x cube as it is derivative of sec x is sec x tan x, and then minus sec x as it is derivative of x cube is 3x square, and in denominator x cube square means in short it is x raised to 6. It is always better to give the answer in simplified form. As far as this tip is concerned, derivative is over, but we have to simplify it further. Observe it carefully, we can take x square common from these two, as well as we can take sec x common. So, x square sec x common in bracket x tan x minus 3 upon x raised to 6 as it is. As well we can simplify, we can have a division with this x square, and therefore, final answer sec x into bracket x tan x minus 3 upon x raised to 6. So, remember this formula. So, product rule and quotient rule, these are most important rule for us. Let us take next one, again very important topic. So, I am saying every time this is important or that is important, but in short we can say that to understand the concept of derivative completely, each and every topic is equally important. So, here derivative of composite function, in short we say that chain rule. What is the meaning of composite function? Here if y is a function of u, I am writing down with the help of arrow diagram, this is called as arrow diagram, y is a function of u and u is a function of x. So, y is a function of u, u is a function of x, so naturally y is a function of x. So, this type of relation is called as composite relationship, and here this is called as y is equal to f of g x. Why? Clear cut we can see that is u is replaced by its functional relationship gx. So, y is equal to f of u, and therefore, here we can write down u is nothing but g of x. So, this is called as composite function. I have expressed this composite function in short with the help of this arrow diagram. So, whenever there is a composite relationship, we have to use the rule, and that is called as chain rule. So, what is the meaning of chain rule? Let us see. Y is a function of u. So, we can find out derivative of y as dy by du. U is a function of x. So, we can find out derivative of u as du by dx. And whenever we say that y is a function of x as well, then it is nothing but dy by dx. So, this is the formula, dy by dx is equal to dy by du into du by dx. So, this is the formula that is called as chain rule. Now, let us understand one example, d by dx of sine of fx. Fx can be anything. So, first of all, we have to take the derivative of original term, that is sine, and derivative of sine is cos. Inside term fx should be kept as it is, and then multiply by derivative of fx, and that is f dash of x. Now, for example, we can see d by dx of sine 3x. So, first of all, we can take derivative of sine as cos of 3x into d by dx of 3x, and d by dx of 3x is 3, and that is why this is answer. Let us take one more example of this chain rule, that is, for example, d by dx of, let us take e raised to sine of x. So, if you want to take the derivative of e raised to sine x, first of all, we are going to take a derivative of e raised to. We know that derivative of exponential term is as it is, derivative of e raised to x is e raised to x. So, derivative of e raised to sin x is also e raised to sin x, and then as per chain rule we have to take d by dx of sin x, and therefore, final answer will read as e raised to sin x multiplied by cos of x. So, this is the concept of the chain rule that we have to understand. Now, let us take chain rule formulae. So, this formula again we are going to remember, there is nothing new in that. What is the change? Derivative of sine you know, that is cos x, derivative of cos, that you know, minus sine, derivative of tan you know, sec square. Only thing is that here inside sine, inside cos we have taken fx. Fx can be anything. Okay. So, these are the formulas that you supposed to remember. You can understand this derivative of outer term first we have to take, and then we have to take derivative of inner term. You can just concentrate on this formula number 7, d by dx of x raised to n. First of all, we have to take the derivative of that bracket, and then we have to take the derivative of the term which is inside the bracket. Now, let us see in this manner. So, d by dx of, for example, 3x square plus 5 bracket raised to 7. So, here first of all we have taken a derivative of that bracket. So, for bracket we can say that 7 comes out, and then as per the formula index gets reduced by 1, and now as per chain rule d by dx of 3x square plus 5. In short, first of all we have to take the derivative of that complete bracket, and then the derivative of the term which is inside bracket. So, this is the best example to understand the concept of chain rule. Now, we can see that derivative of 3x square is 6x, derivative of 5 is 0, no need to write down, and ultimately final answer is 42x into 3x square plus 5 bracket raised to x. Okay. Now, let us see certain more formulas, that is d by dx of root of fx. Again basic formula is used. We must know derivative of root x, derivative of root x is 1 upon 2 root x. Instead of x we are using fx. Whenever it is d by dx of root x, formula is 1 upon 2 root x. What is the only change? Instead of x it is fx. Okay. And then whenever it is fx we have to take its derivative as f dash of x. As far as formula number 10 is concerned, I have just solved the example based on that, that is e raised to sin x. Okay. So, all these formulae must be known to you. So, there are as many as 12 formulas on this chain rule. Let us take now certain examples. The example is same whatever I explained just now. D by dx of 5x plus 3 bracket raised to 6 means 6 will come out and then the index will get reduced by 1. So, 6 into 5x plus 3 bracket to the power 5 multiplied by chain rule d by dx of 5x plus 3. Derivative of 5x is 5, derivative of 3 is 0, never write down this, derivative of 3 is 0, no need to write down, and then final answer must be given in simplified form. Similarly, d by dx of sine of 6x, first of all take the derivative of sine, derivative of sine is cos, 6x must be written as it is, then as per chain rule d by dx of 6x which is 6, and therefore final answer 6 cos of 6x. And then next example, d by dx of root of tan x, first of all derivative of root, that is 1 upon 2 root into d by dx of tan x. So, we can observe that it is in the form of d by dx of root of fx. So, that is 1 upon 2 root of fx multiplied by f dash of x. So, it is clearly indicated that all formulas can be used very easily while solving the example. So, derivative of root of tan x is 1 upon 2 root tan x and into derivative of tan x is sec square of x. Now, let us see one further examples, that is derivative d by dx of 1 upon log x. So, for d by dx of 1 upon log x we can use one shortcut formula of quotient rule, that is d by dx of k upon v. So, k is a constant term. So, whenever numerator term is constant, no need to apply entire quotient rule. We can use this shortcut formula. Here numerator is minus k upon v square multiplied by dv by dx. Why it is so? Because we know that derivative of k is 0. In our regular quotient rule formula, what is the formula? V into du by dx means denominator into derivative of numerator. Since k is a constant, derivative of numerator is 0. So, this is the shortcut formula. Now, observe this 1 upon log x. So, whenever we say that d by dx of 1 upon log x, observe it, constant term is there in the numerator k, and that is why minus 1 upon v square means minus 1 upon log of x whole square into we can take d by dx of log of x, and we know that d by dx of log x is x, and that is why this is answer, that is minus 1 upon x into log of x whole square. Now, this example is similar to that of e raised to sin x. First of all, we have to write down the derivative of exponential term as it is, and then derivative of sec x, and derivative of sec x is sec x tan x. Now, d by dx of a raised to cosec x, for that you must know the formula for d by dx of a raised to x. Formula of derivative of a raised to x is a raised to x multiplied by log of a. Now, instead of x there is a cosec x. So, here a raised to cosec x into d by dx, and here we also have to write down log of a. Okay. So, a raised to cosec x into log of a, this is the answer. So, final answer can be written as minus cosec x into cot x multiplied by log of a, and then we can write down a raised to cosec x. So, always remember that whenever we find out derivative of a raised to cos x, it is in the form of log of a. So, log of a is also there in the formulae. Okay. Let us go for one more example, e raised to tan of 5x. So, derivative of exponential term again as it is into d by dx of tan of 5x. Now, observe that there is a composite relationship for one more time, because e raised to tan and inside tan there is 5x, there is no only x, and that is why we have to use chain rule twice, that is e raised to tan 5x, sec square of 5x is the derivative of tan, and again since inside sec square 5x is present, we have to take the derivative of 5x as well, and that is nothing but 5. So, final answer 5 into e raised to tan of 5x into sec square of x. Okay. One more important topic, logarithmic differentiation. You must be knowing, when we take the log, whenever number of terms are in the form of index, product, quotient of different functions, then only we have to take log. So, whenever there is a index form, for example x raised to x, it is a index form of two variables. Then for example, if log of x multiplied by sin of x multiplied by a raised to x, there is a product of different functions. Then for example, quotient sin of x multiplied by e raised to 2x derived upon tan of x. So, there is a quotient. So, whenever there is variable raised to variable, product of different variable functions and quotient of different variable functions, in this case we have to use this logarithmic differentiation. What we are going to do? We can use this formula, derivative of log of fx is, as per chain rule, derivative of log is 1 upon fx into derivative of fx is f dash of x. Now, we can see that this method is very useful, particularly for this type of relationship, y is equal to fx raised to gx. This example of this particular function is y is equal to x raised to x. Here fx is x, gx is also x. So, same concept, that is the concept of logarithmic differentiation we have to use here. So, for example, y is equal to sin x raised to x. First of all, we have to take log on both sides. So, if we take log on both sides, we get log of y is equal to log of sin x raised to x. Now, laws of logarithm must be known to you. So, whenever it is log of sin x raised to x, x will come out and it will be a multiplier of log of sin x, and then further we have to differentiate with respect to x. Now, in LHS there is log y. So, for log y as well we have to apply chain rule, that is derivative of log y is 1 upon y, and do not forget to take the derivative of y, which is nothing but dy by dx. And now, in RHS there is a product of two functions. So, naturally we have to apply the product rule, that is derivative of the first term, that is x, log sin x as it is, and then plus x as it is, derivative of log of sin x. So, this is the product rule whatever we applied over here. Simplify further, and instead of writing down d by dx of y, we can write down in short as dy by dx. So, derivative of x is 1, log of sin x as it is, and now we have to apply chain rule here, because there is a combination of two functions, one is logarithmic and one is trigonometric, that is log of sin x. So, first of all derivative of log is 1 upon, so here it is 1 upon sin x and multiplied by derivative of sin x. So, this is again application of chain rule. Then in this particular example we always have to transfer this denominator y to other side, and y into log of sin x as it is, and here derivative of sin x is taken cos x, and we can give the answer in simplified form in this manner. Okay. So, also logarithmic differentiation can be used if y is expressed as product and quotient of different function, whatever I explained to you earlier. So, here we can see that y is equal to e raised to 2x, x minus 2 bracket to the power 3 by 2 upon x plus 1 bracket raised to half. Observe that here numerator there is a product of two functions, and as well as in denominator there is 1. So, only one way of solving such example, and that is logarithmic differentiation, taking log on both sides. So, here we are having log y is equal to log of everything, and now we have to use laws of logarithm. We know very well, if it is in the form of log of m into n upon p, we can express that as log of m plus log of n minus log of p. Whenever we are taking log on both sides, always remember this log we are taking as a natural log. Natural log means log to the base e. We generally represent it only with log. Sometimes natural log can also be represented with the symbol ln. Always remember, this log is never of base 10, this is always to the base e. So, log of e raised to 2x plus log of x minus 2 raised to 3 by 2 and minus log of x plus 1 bracket raised to half. Exactly in the same manner, numerator term are in the form of addition and denominator term is in the form of subtraction. Now, log of e raised to 2x, that exactly I am talking that it is a natural log, and that is why log of e raised to 2x can be written directly as 2x. Why? Because log of e raised to 2x, so as per laws of logarithm, it becomes 2x into log e, and whenever log e to the base e is there, it is always 1. So, this can be written directly. Again laws of logarithm here, 3 by 2 can be shifted over here, 1 by 2 can be shifted over here, and then after this we can go for a differentiation. So, differentiate with respect to x, again same concept, derivative of log is 1 upon y, as per chain rule derivative of y is dy by dx. And now here also we have to apply chain rule, that is derivative of log 1 upon x minus 2 into derivative of x minus 2. Here also we have to apply chain rule, because it is log and inside log there is x plus 1. If it is only x, then that is not called as a chain rule, it is x plus 1, and that is why here we have to write down in this manner. So, understand particularly when we are using chain rule, if there is only log x, in this case derivative is 1 upon x, but if it is log of x plus 1, we have to apply the chain rule. What is the chain rule? That is derivative of log of x plus 1 is 1 upon x plus 1 into x plus 1. So, this is the important point to be noted when we are going to apply chain rule and when we are not going to apply chain rule. Always remember, when any function, if only x is present, no question of chain rule, because all our standard formulas are related to x only. Now, let us proceed further. This is important formula, even we require that in our 12th standard CET as well as first year engineering. So, remember this, derivative of x raised to x is x raised to x into bracket 1 plus log x. Now, one more important topic, derivative of parametric functions. What is the meaning of parametric functions, that we have to understand first. Let us assume that y is expressed in terms of t and x is also expressed in terms of t. In short, y is equal to f of t and x is equal to g of t. So, when two variables are expressed in terms of third common variable, that is called as parametric functions, and t is called as a parameter in this case. You must be knowing certain parametric equations. If you remember your 11th standard conic section, that is parametric functions for a circle is x is equal to a cos theta and y equal to a sin theta. So, these are called as parametric functions for or parametric equations for a circle. As far as ellipse is concerned, it is y is equal to b sin theta. Okay. So, parametric functions we already learned in our earlier standard. Now, here we have to take the derivative of parametric functions. So, derivative of parametric function, this is the formula. In numerator, we have to take a derivative of y with respect to t, that is dy by dt, and denominator we have to take derivative of x with respect to t, that is dx by dt. Let us see this example, x is equal to a sin theta and y is equal to a into bracket x is equal to a into theta minus sin theta and y is equal to a into bracket 1 minus cos theta. Observe that now x is f of theta and y is g of theta. In short, we can say that theta is a parameter. So, to find out dy by dx, we need to find out dy by d theta in the numerator, and then we need to find out dx by d theta as well. Okay. Now, let us see that how to find out this. So, differentiating with respect to theta. So, dx by d theta is equal to, we have to find out its derivative. So, what is x? X is given in earlier slide, it was a minus sin theta, okay, and y is equal to a into bracket 1 minus cos theta. This was the question. Now, let us see that dx by d theta. So, a as it is, theta is just behaving like x. We know that derivative of x is 1 when you differentiate with respect to x. So, in the same manner derivative of theta is 1 when we are differentiating with respect to theta. Derivative of sin theta is cos theta. Then y is equal to a into bracket 1 minus cos theta. So, 1 is a constant term and that is why its derivative is 0, and derivative of cos theta is minus sin theta. So, minus of minus it become plus, and now this formula is to be applied for parametric differentiation. Dy by dx is equal to dy by d theta upon dx by d theta, just by putting all these values. As I told you earlier, we always have to give the answer in simplified form, and here observe that a gets cancelled, and to simplify this we have to use half angle formulas of trigonometry. Half angle formula for sin theta is 2 sin theta by 2 cos theta by 2, and 1 minus cos theta is 2 sin square theta by 2. Simplify further, so we get final answer as cot of theta by 2. So, remember, for parametric equations we need to find out dx by d theta and dy by d theta. If theta is a parameter, parameter may be anything. In this example it is theta, in another example it might be t or even any other variable. Okay. Now, one more important topic, and derivatives of implicit functions. First of all, you have to understand the meaning of implicit functions. So, whenever equation is expressed in the form of y is equal to fx, then it is called as explicit function. As far as all earlier examples were concerned, all were explicit function. But when x and y cannot be separated, if I say that you take all y terms to LHS and if take all x terms to RHS, if you are able to do this, it is called as explicit. But if you are unable to express y in terms of x, in other words you cannot separate y to one side and x to other side, that is called as implicit function. Take this example, x cube plus y cube minus 3xy equal to 0, and try to take all x terms to one side and y terms to other side. You will find out you will be unable to do this, and that is why such type of equation is called as implicit equation. Okay. So, this is the another example, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This is the condition of pair of lines, if you remember your 12th standard pair of lines topic. Now, we have to differentiate this. What is the difference now? In our earlier example, y was on LHS and other terms on RHS. So, derivative of y we are taking directly as dy by dx, but now we have to take the derivative of y wherever it is present, and accordingly we have to apply product rule, chain rule, quotient rule, whatever it is. So, ax square. So, when you differentiate with respect to x, derivative of x square is 2x. Now, observe that it is 2hxy, means it is a product of xy. So, we are supposed to apply product rule, 2h as it is, then d by dx of x into y. As per our rule, derivative of the first term, second term y as it is, plus x into d by dx of y, means second term as it is, derivative of, or second term as it is, first term derivative. So, accordingly we can apply product rule. Derivative of by square. Now, important, whenever we are taking derivative of ax square, derivative of x square can be written directly as 2x, but since we are differentiating with respect to x, derivative of y square is 2y, and this is important, that is we also have to take the derivative of y. Similarly, in this case 2fy. So, whenever we are taking 2f is a constant term, do not forget to derivative of y. So, derivative of x is 1, but derivative of y is not 1, that is dy by dx, because we want to find out dy by dx. So, simplify further. So, here derivative of y is written as dy by dx, derivative of y is written as dy by dx everywhere, and then we can simplify it to get the final answer in this manner. So, this is the final answer of dy by dx. We can simplify this. Okay. So, this is implicit function. Always remember, what do you mean by implicit? That is when x and y cannot be separated. Now, derivatives of inverse trigonometric functions. These are the formulas that you have to remember. You can do the revision of these formulas. That is, for example, derivative of tan inverse of x is 1 upon 1 plus x square. Then derivative of cot inverse x is minus 1 upon 1 plus x square. What is your observation? That is, derivative of tan inverse and derivative of cot inverse, they are equal and opposite. Derivative of sin inverse is 1 upon under root of 1 minus x square, and derivative of cos inverse is minus 1 upon under root of 1 minus x square. As far as derivative of sec inverse x is concerned, it is 1 upon x into under root of x square minus 1. It is again same, but with the negative sign. Why it is so? Why derivative of tan inverse and cot inverse are equal and opposite? Why derivative of sin inverse and cos inverse are equal and opposite? You can see the reason here. The reason is that these are the standard trigonometry inverse function formulas. Sin inverse x plus cos inverse x is always equal to pi by 2. That's why derivative of sin inverse and cos inverse are equal and opposite. Why? See here. If I take a derivative, d by dx of sin inverse of x we can take, plus we can take d by dx of cos inverse of x, and then here we can see derivative of pi by 2 is 0, and therefore we can say that d by dx of sin inverse of x is equal to minus d by dx of cos inverse x. So this is the reason why the derivatives of sin inverse, cos inverse, tan inverse, cot inverse, and sec inverse and cosec inverse are equal and opposite. So this is all about basic concept of derivatives. We will see further concept of derivatives in our next video. Thank you very much. Thanks a lot.